Alright, so in this video, we're going to be doing some practice with finding direction angles, okay? Now, if you're not sure what direction angles are doing or what they are, here you go, you have a picture right here, and I showed you this in the explanation video, and I chose not to take it down because I'm extremely proud of it and really scared to erase it because I don't know if I'll be able to do work that amazing ever again. So, without further ado, let's hop into our problem. We want to find direction angles for the vectors. We have vector A, which is -3, 6, 12, and we have vector B, which is 4, -1, -7. Okay, so let's start off with our first vector, vector A. Okay, you see here that we already know A1, A2, and A3. All right, we know that. Okay, but we don't know the magnitude of A, and that's the first thing that we need to find. So let's do that. The magnitude of A is going to be equal to the square root of all of our components squared added together. Okay, so the sum of the squares. So now you have a -3 squared plus 6 squared plus 12 squared. Okay? And, well, -3 squared, that's 9, plus 36 is going to be 45, plus 144 is going to be 189. Okay? So you get that this is equal to the square root of 189. Alright? Now, you can simplify this, and, I mean, you can simplify if you want to. I don't really think you'll get points off for not simplifying, depending on how picky your professor was, but mine didn't really care at all. So you can simplify this by taking out a 9. Okay, you can see that 9 times 20 is 180, and that's just 9 more. So this is the same thing as 3 rad 21. Okay, just taking out a rad 9 there. Now, what can we do with this? Well, first we can write out our direction cosines, and then we can find our direction angles. Okay, so we have the cosine of alpha equals A1, which is -3, over 3 rad 21. And that's the same thing as saying -1 over rad 21. Okay? Now, the cosine of beta is equal to, well, A2, right? What's A2? That's the second component. That's 6, okay? So now we have a 6 over 3 rad 21, same thing as saying, well, I'll write it out here. 6 over 3 rad 21 is 2 over rad 21. And, of course, we have cosine of gamma. That is equal to 12 over 3 rad 21, which is just going to be 4 over rad 21. All right, so finally you get that, and I guess I'll have to go back over here. Geez, you get that alpha is equal to the cosine, the inverse cosine of -1 over rad 21. You get that beta is equal to the inverse cosine of 2 over rad 21, and you get that gamma is equal to the inverse cosine of 4 over rad 21. So there, right there, those are your direction angles. If you're not sure what those are telling you, there it is. That beautiful picture right there. All right, so now let's move on to our next vector. Okay, now we're talking about vector B. And vector B is 4, -1, -7. Okay, now we know the first component, the second component, and the third component of that vector. Okay, 4, -1, and -7, right there. But we need to find out the magnitude. So let's do this again. The magnitude of B. That is going to be the sum of the squares. So you have 4 squared plus a -1 squared plus a -7 squared. Okay, and that is going to be equal to, you have a rad 16 plus 1 plus 49, okay, which is a 50 plus 16, that's going to be rad 66, okay? So now you get your magnitude of B. So let's write out our direction cosines. We have that the cosine of alpha is equal to well, this is going to be A1, well, your first component, okay? It could be B1, C1, whatever. All right, that is, it's 4. And that's going to be over the magnitude of our vector, which is rad 66. Cosine of beta is going to be the second component, which is -1. And that's going to be over rad 66. Lastly, we have cosine of gamma, which is going to equal the last component, -7, over rad 66. All right, and now what we have to do is just take the inverse cosine, okay? So we get that alpha is equal to the inverse cosine of 4 over rad 66. We get that beta is equal to the inverse cosine of -1 over rad 66. And we get that gamma is equal to the inverse cosine of -7 over rad 66. All right, and nice, better spacing this time. All right, there, right there, that is your direction cosines. So really, that's it. Nothing too hard at all here, okay? Now, this is definitely something that you'll want to go back and review before you have a chapter test or a section test, anything like that, okay? Because this is definitely something that's a little easier to forget, okay? You just need to know your direction cosines, and honestly, you'll be set, okay? Honestly, I was never asked on a test what they stood for. I was more asked to just find your direction angles or direction cosines, okay? And if they ask for direction cosines, just leave it like that. That's what your direction cosines are. All right, so that's basically just some insight on what happened with me. Okay, I was only asked to just find the direction angles or the direction cosines. All right, so that's going to do it for this video.
So if this video helped you, make sure to leave a like and subscribe by clicking my icon in the top left. You can also view the playlist for vectors and the geometry of space, the explanation video for direction angles and direction cosines in the next video in the series. Lastly, if these videos are really helping you, consider supporting me on my Patreon, which I have linked in the description down below, along with some other pretty cool links that you should definitely check out. See you soon.